Hello everyone, am I audible? Okay, fine. So let's start. So in last class we were talking about like NumPy, and before that we were talking about pandas. So in today's class we are going to start with the visualization. So again, visualization is one of the like important part when it comes to when it comes to understanding about the data set and the trend of the data set and all those things. So let's try to understand it. Let's try to see like how it works basically in terms of visualization and how we can visualize our data set. So in this entire classes, so I will be talking about different libraries. So first of all, I would like to start with the matplotlib, which is one of the most famous and widely used I can say libraries for visualization in Python. And then I'll talk about a Seaborn. Again, it's one of the most powerful library. And then I will talk about a Plotly and couplets, which has been used to represent a data set into a dynamic way. So let's try to understand that what is the meaning of this dynamic way of data visualization. So data visualization, Plotly. Okay. So these are the things that we are going to understand over here. So far, so forth, we have seen how we can do a data manipulation with respect to a data frame. We have seen like what is a meaning of a series. We have seen many more things so far, so forth. So in this section, so mostly I will be talking about like visualization of the entire data set, so that when we will talk about the EDA, exploratory data analysis, so this is going to help you out. And again, so whenever you will build a machine learning model, so at that point of a time, so in terms of analysis of a data, so these things are very much important, and these things are something which is going to help you out to understand a trend. So unless and until you are not able to understand a trend with respect to a data set, so for sure you will not be able to build a better model. So always to build a better model, or to like build a better kind of data, to do a better kind of a data analysis. So these things are very much important that we are going to discuss. So like I said, so first thing is like matplotlib libraries, which I'm going to talk about. So let's try to talk about this one. So fine. I'm trying to import a NumPy. I think we all are aware about NumPy. I'm trying to talk about I'm trying to import a pandas. I think we all know pandas. And this Seaborn is not important as of now. Seaborn is just another libraries which provides you different kind of packages or different kind of methods for plotting a data set, to analyzing a data set in terms of a visualization. And matplotlib is again equivalent to a Seaborn. It's another libraries. So I will be talking about first of all matplotlib, and then I will talk about a Seaborn. For Seaborn, so we have a separate session itself. So we have a separate slides, and these are the 3 slides that I have already uploaded over here inside your dashboard. So in this section, so these 3 files are already available. You can download it and you can practice it with me. And till this section, so I think we have covered, and this is the objective and subjective assignments that we have given to you here. So you will be able to find out that we have given you some assignment with respect to EF4 dataset, and EF4 dataset is an open source dataset. You can try to download it from anywhere. It's an open source dataset. You will be able to get it as of now. So I've just given you a question. Dataset is not available over here. I'm completely aware about that, and I'm just asking you like, okay, fine. So go to internet and then download it, so that like at least like you will do some kind of a contribution towards it. Fine. So now I'm trying to like write this line number 5, which is in this way, like a percentile of matplotlib and then space and then inline. Some of you will be able to find out, or some of you will be able to print a graph even without this line. But if you are using an older version of Anaconda distribution, then in an older version of Anaconda distribution, to show all of those graph inside your console, so this line is important. If you have installed a latest version of Anaconda distribution, I'm assuming that all of you have installed a latest version itself. So in this case, this line is not relevant. You can remove this line, and even in that case, you will be able to get your final outcome. That is completely fine. So fine guys, let's start with this visualization. So first of all, what is visualization and how it is different from a dashboarding? Dashboarding by, so you can try to create a dashboard into a Tableau or a Power BI or maybe a Click View or a Javelin, or like there are different kind of tools or frameworks which is available in which you can try to do a visualization. If you are using R, then there is a package called a Shiny R where you can try to do a interactive visualization. Now as a data scientist, whenever you will start building a solution, so first of all we always try to understand a trend of the data set, that okay, so what is a pattern my data set is going to showcase, and based on that pattern, so we used to take many kind of a decision that what kind of algorithm we should use, or like whether I have some outliers inside my data set or not, or like what kind of a data conversion that I have to do. Many things you will be able to analyze just by looking into a graph. Suppose if I have given you 1 million record, if I'll ask you, okay, fine, so give me a pattern in between a data set. For sure, you will not be able to read out the 1 million records, and you will not be able to memorize each and everything, and you will not be able to give me, you will not be able to suggest me any kind of a pattern in between a data. But at the same point of a time, if you can visualize those 1 million, you will be able to get a pattern, and you will be able to give me some kind of insights about the data. This is where visualization things comes into a picture, and that's the reason, so you should know about, you must aware about some kind of a visualization libraries. So in visualization, so in general, so we try to plot a different kind of a graph, like a scatter plot, or maybe a bar plot, maybe a line graph, maybe a histogram, maybe a matrix plot, I can say, or maybe like different kind of a plot, like KD plot you can try to draw. So there are various hundreds of plots which is available, and depends upon the requirement, so we try to plot it. So again, you must be having confusion that okay, there are many kind of plot, and which kind of a plot I should use in what kind of a instances, in which kind of a situation. We will try to clarify all of those things as we will progress inside this classes. So fine, now here what I'm trying to do is, so I'm trying to create basically data in a first place. First of all, like if I have to do a visualization, so first of all I will have to create a data. Unless and until I don't have a data set, so what I will visualize? Nothing, basically. So that's keeping these things in my mind. So I'm trying to create a data frame over here, and my data frame is nothing but I'm trying to call pandas.data frame, and I'm trying to generate 100,000 random values. As we all know that what randin does, so randin always try to generate a random data set on a normal distribution, on a normal distribution scale. So try to generate a data set. This is what our understanding is so far, so forth. So it is going to create 1,000 data set, 1,000 data point. This is what randin does, and randin is basically a function which is available inside a numpy.random. So I have already imported all of those functions, and these functions are available as you can see, or else you can do numpy.random.random or numpy.random.random, and then you will be able to generate a data set. So this is what we have discussed already inside the numpy. So here I'm trying to generate thousands, I can say, data points, and for all of those data points, so suppose if I'm trying to write maybe a pandas.data frame, and then if I'm going to enclose a rand in within that one, so I know that okay, so it is going to create 1,000 data set. It is going to create 1,000 data set, and whenever it is going to create 1,000 data set, I have not given any column name, I have not given any row name over here. So by default, it is going to start a column indexes from a 0, and again at the same point of a time, so it is going to start row indexes starting from 0 till the data. So fine, till the data. So 1,000 cross 1, this is the data frame that we have created. Now, so I wanted to give my own column or own row name, and that we know that that is possible basically, because in pandas data frame manipulation, so we have seen that we can try to provide our own row name, and we can try to provide our own column name. So this is completely feasible, and this is what I'm trying to do over here. So I am trying to basically give a index name. Now I wanted to give a specific index name over here. So I wanted to give a index name as a date range, and that's the reason. So I'm trying to call a pandas dot date range, and date range is a function. Date range is a function basically which is available inside a pandas, so which always deals with the dates. I would say. So here I'm trying to give a date, one specific date, and then I said that okay, fine. So period is equal to 1,000. So in this way, it will try to generate 1,000 dates. Now you can try to generate 1,000 dates based on the day, based on the week, based on the month, based on the year. That is completely fine. So on that specific intervals, it will try to create a date. Simple. I'm trying to create some data set in terms of a date. That's it. Nothing else. Then I'm trying to give my own column name. Column name is equal to values, which I have given. So now if I'll try to print this data frame, so this is how it looks like. This is the data frame that I have created over here. So this was the data frame that I was created from like 1,000 random values, and here is the data frame that I will end up generating. A simple data which I have generated, nothing fancy. That is completely fine. Now, so let's suppose if I wanted to do some data manipulation, cumulative sum operation kind of a things if I wanted to do. So in that case, I can try to call data frame inside that. So I'm trying to select a value column, and then I'm trying to call a cum sum. Cumulative sum I'm trying to call over here. So a cum sum wise, if I'm trying to call over here, so cumulative sum is nothing but it's a summation of a previous data set and the current one. Let me execute it again because it's a random value, so it will keep on changing. Now here, so you will be able to find out that if I have called a cumulative sum over here, and then if I'm trying to override this data frame again, so the first data is this one. The second data which I have created is nothing but this plus this. So this plus this is equal to the new values, because before that there was 0. So 0 plus this one is equal to this value. Now this value you will be able to find out. Now this value, I will say this value plus next value. This value plus next value is equal to the next value. Then again, this value plus this value is equal to the next value. This is what is called as a cumulative sum. So cum sum. Cum sum is a function which is available, and cumulative sum is nothing but the output minus the next data set. That's it. So cumulative sum is nothing but, you can say the next n is nothing but n minus 1, n minus 2. So summation of n minus 1, n minus 2 is equal to the nth element that you will be able to get. That is called as the cumulative sum. So simple method is available over here. So fine, by doing this, I will be able to create this data. So that is completely fine. Now, so this is the data frame that I have. Now, if I wanted to plot this data, if I wanted to check the behavior, that how with respect to a date, my value is varying. So if I wanted to check that, if I'll ask you a question that, okay, fine. So date index is given over here, and then respective dates are given over here. Now, just tell me that how these things are varying. So with respect to a date, because you will be able to find out that my date is available into a ascending order, because I have generated a dates and I have made that dates as a indexes. So how this dates is varying with respect to a value, if I'll ask you a question. So for sure, just by looking into a data set, you will not be able to give me any kind of answer. So how you will be able to give me answer? If you are able to plot it. So to plotting wise, so I'm trying to call, I can try to call, this was a data frame. So I can try to call a data frame dot plot. So data frame dot plot plot, and then so I can try to execute it. And in this way, you will be able to find out a beautiful pattern between indexes and between a data set that you have. And that is not at all a tough. It's very easy. I've just written like a data frame dot plot, and then I'm able to get this particular graph. Now, if you look into this graph, so in this graph, we have a x-axis and we have a y-axis, because in a graph, whenever we are talking about a graph, so it could be a 2D, it could be a 3D. So we have a x-axis and we have a y-axis. If I have to represent any of these points over here, so we should know x coordinate and we should know y coordinate. If we know x coordinate and if we know y coordinate, then only I will be able to represent a particular point. So point is nothing but it's a combination of x and y over here. Now this was my data set. This was my data set which I have taken. I have taken the entire data frame dot plot I have given. Now automatically, so whatever indexes that you have given over here, so whatever indexes you have given over here, so it will try to consider all of those indexes as a x-axis, and then whatever respective values that you have given over here, so that will be considered as a y. So index will be x-axis, and then like values will be available on a y-axis. So as you can see over here, so values are available in a y-axis, and then indexes are available into a x-axis. So you will be able to see that as we have taken our date range function over here, that's the region. So in terms of a representation of all of those date range functions, so this is how it represents. So June, July, so July this to June 2020, so July 2019 to this one, then this to this to this to this. So whatever interval that you have taken, so automatically it creates all those interval, and then it will try to fit your data set within a graph. So now you will be able to find out a trend that, okay, fine, so sometime my data set is going till this point, sometime it is going down as this one -10, sometime it is going high as this one, sometime it is going down, sometime it is going up, sometime it is going down again, so forth, so forth, so far so forth. And so I'm starting from a 2019 and I'm going till a 2022 over here, and this is the data trend which I will be able to get. A very simple approach, right? I'm able to get, and this is how like it is going to help you out. So again, this is by default a line graph kind of a things which I have plotted over here. It could possible that I can try to plot a different kind of a graph. Now if I'll try to check the argument of the plot, so if I'll try to talk about a default argument, you will be able to find out that okay, so data wise it can possible that it can be a series or it can be a data frame. X label or a position default, it's equal to none, only used to data frame. So I'll talk about how you can try to provide a custom X, custom Y for sure. Now, so kind is equal to line by default, but you can try to plot any kind of a graph, and that is possible. Let's suppose if I'm trying to plot kind is equal to maybe a scatter plot. So that is also possible, and I will be able to do that. So here to plot a scatter plot, so first of all what I have to do is, so I have to pass or I have to define my X value and I have to define my Y value, which I will show you in a later stage. So kind wise, so there are a bar graph, there is a histogram, there is a box plot, there is a KD plot, there is a density graph, there is an area plot, there is a pie plot, or there is a scatter plot or hexabin plot. So these are the plot that you will be able to do. So almost every kind of a plot we are going to see in our respective session. So in this session itself, so almost every kind of plot we are going to like discuss over here. So as you can see, so if I'm trying to give kind is equal to scatter plot, so it is giving me error. So it is not able to understand that what I'm talking about as of now. So if I'm going to talk about a scatter, because if you will look into this one, so scatter requires a X and the Y column. So whenever you're talking about a scatter plot, so you are specifically supposed to talk about basically a X-axis value and a Y-axis value. So suppose if you have a data frame, now if you have a two columns, if I wanted to do the comparison that how one column is moving with respect to other column, so in that case I can try to select a column, I can try to put that as a X value and another column as a Y value, and then I will be able to get a plot. It's again very easy, and we will try to understand those things in our upcoming sessions, as I'm trying to show like a scatter plot many places, I would say, even in this slide and even in next slide. So I'm trying to talk about the scatter plot where I have given like a X values, where I have given a Y values. It's very easy, it's not a big deal, I would say. So let's try to understand it one by one. I think that will be much better. So here plot. Now, so plot wise, it is trying to plot all of those things over here. Now, apart from that, what I can do is I can try to set a figure size. Figure size means what? So figure size means the window which it is going to use, and it's very common. You will be able to observe it. So I have given figure size equal to 5 cross 5. Maybe I can try to give 5 cross 50, and in this way you will be able to find out that it is trying to represent length and the width. So now if I'm going to write like a 50 cross 50, that is completely fine. So it will be able to plot it. So you will be able to get your graph into a much more detailed way. This is how it will happen. So you will be able to control your entire window size, and then based on that you will be able to print your graph. Again, you can try to save this graph. So there is just a function called as a graph.save. So you have to create a figure, then object of figure, and then figure.save, and then it will be able to save in a PNG format, into a JPG format, in any format that you want. So it supports almost all the popular formats in which you will be able to save your graph, and then you can try to put it in an Excel sheet, or maybe you can try to publish it somewhere. So many things are possible in terms of this one, and this is what we are going to talk about. So fine, again here. So this was just a basic. This was just a basic that I was trying to call a plot, and then I was able to plot it. Now, so here, so I'm going to load a data set. So I will load some kind of a data frame, and then based on that, so I will try to show you a different kind of a graph. So here I'm trying to load a data set called as iris data set. So iris is an open source data set, so you can try to load it directly from the file, or you can try to load it directly from the like a graph library itself. So almost in all of these libraries, these are the open source data sets. So there are some data set which is already available. So I'm trying to call SNS Seaborn basically. So SNS is nothing but it's an alias of Seaborn that I have created over here. So SNS dot load data set, and I'm trying to load basically a iris data set over here. So iris data set is a data set about a flower. Now, so like you will be able to find out many different kind of a data set which is already available inside the SNS packages. Now, so let's suppose if you don't want to load the data set from this one, so simple, do one thing, go to Google and try to search IRISH data set basically, and CSV downloads. So you will be able to get a data set just in a first line itself. So go over here and you can download it. So no one is going to stop you. You can download it directly over here, or else so you can try to call this data set from a directory or library itself, and even in library these data sets are available. So I'm just trying to show you because I just need some data frame which I can plot. That's it. That's the whole purpose behind doing that. So here I'm trying to call this data set, and iris is a data set about the flowers in which, so there are 4 properties you will be able to find out: sepal length, sepal width, petal width. And then there will be a 5th column that you can find out, which is called as a class or a species. So these are the feature column you will be able to find out, and this is the label column that you will be able to find out that, okay, so if this is the sepal length, this is the petal length, this is the sepal width, this is the petal width, then this will be the flower classes. So classes wise there will be 3 classes you will be able to find out over here: Setosa, Virginica and versicolor. Here I'm just showing you 5 data sets. That's the reason you are able to see only Setosa, but Setosa, Virginica and versicolor. So these are the 3 types I will say which is available inside a iris data set. So fine guys, not a problem. So let's try to understand that how we can understand the property of this data. So this is the data set which is being given to me. Now someone is telling me that, okay, so give me insights, insights about this data set. So we will try to understand that how I will be able to extract a different kind of insights out of the data set. So let's try to understand it. Yeah. So here what I have done is, so I'm trying to create a data frame, and then data frame dot plot, same as the before. So data frame dot plot, and then so I'm trying to define my figure size. I think we all understand the figure size. Figure size is nothing but it's a size of the window in which it is going to give you an output. So I'm trying to define a figure size over here, and then so there are many more parameters that you will be able to find out, which you can define, which you can give basically, like a kind or title or figure size, grid, legends, style, log x, log y, log, and all those things, y lim, x lim, and all those things. So one by one, I will talk about those parameters. So here title means, so whenever we create a graph, right? So we used to give a title that, okay, fine. So this is the title of this particular graph. So I can try to give a title over here. So I'm going to give like a title, iris dataset. So I can give any kind of a name over here. So it doesn't matter at all. And if I'm going to execute it, if I will try to execute these things, you will be able to find out that this is the title which has been given. So this is the title which has been given over here. So title is this one. Now, so if I wanted to give a title, plus if I wanted to give a label to x-axis as well as y-axis, so I can do that as well. So this is the object. So object dot set x label, set y label, whatever string you are going to pass over here, that will be the label of your x and label of your y. By default, if without giving these things, if you are going to create a graph, so for sure, like it will not try to give a name. As you can see, this is the x-axis, this is the y-axis. So basically you can try to write any kind of a name over here as a x-axis, any kind of a name as a y-axis, so that people will be able to understand. This is just for the people understanding, because we used to create a graph so that people will be able to understand something just by looking into your graph. So that's the reason. So I have given a no, I have, okay. So I have given basically like a title of this entire graph. I have given a x-axis, I have given a y-axis. So I have just given all of those things in this particular place, and that is completely fine. And then it is able to plot each and everything. I'll try to understand the meaning of this plot for sure in some time. So here you can say that, okay, fine. So here we are trying to plot something, but there was no graph name, which I have mentioned. There was no x-axis name. There was no y-axis name, which I have mentioned. So for sure, as an unknown person, you will not be able to understand my graph. But if I want you to understand my graph, for sure, you are supposed to give a proper graph name. You are supposed to give a proper x-axis name, proper y-axis name. And this is how I'm able to give. It's very simple. And always you are just supposed to follow these kind of things. That's it. Now axis dot, and you will be able to see different kind of methods which is already available. So yeah, just keep on pressing a tab and it will be able to show you the list of each and everything which is possible and which is available. Now, so let's try to understand a meaning of these things. What is the meaning of this graph? So if you will look into this data frame, so you will be able to find out that sepal length, sepal width, petal length, petal width, and these columns is having a numerical values. And then a species, if I'll talk about, so species is having a categorical data, or I can say string data set or object data set it is having. Now, so okay, someone is saying that my sound is breaking. Is it? Anyone who can confirm my sound is not breaking? Ashish Patil has said that. No, Ashish, so my sound is not breaking. So maybe you can check your network, because I guess people are saying that my sound is like completely fine. So most, yeah, almost like a 99% people. Okay, yeah, guys, I got your response. Thank you. So no, my voice is not breaking, and if it's breaking, I think you should check your internet connection because of lockdown. So I know in many places, so we are facing this kind of a issue. But as of now, my internet is fine. When I will face some kind of a issue, I'll let you know so that you will be aware about that. So here, what I'm trying to do is, so I'm trying to call this iris data set. Yeah, I'm trying to call this iris data set, and this is basically a data frame. And in this data, I have a 4 column which was having a numerical values, and I have a 5th column which is having a categorical values like a setosa, virginica, versicolor. You will not be able to see setosa, virginica, and versicolor because it's available. If you'll try to print the entire data set, you will be able to see all those things. So these 4 like a column was having like numerical values, and if I'm trying to call a plot by default where I'm not specifying that what kind of a plot I'm looking for, so by default it will try to go with the line plot. So it will try to plot all the data set with respect to a lines. Now, so here on a x-axis, so it is going to plot. So if you will look into this data, so the total number of the data set that I had over here, is 150 rows, 150 indexes. And even in last case, if you remember, we have seen that in a x-axis it is going to plot an indexes by default. So the same thing, same pattern, you will be able to find even over here. So it is trying to represent my data set starting from the 0th indexes, till 150th indexes. This is what it means. So on an x-axis, by default, it is going to consider indexes. On a y-axis, it is going to consider your data set. Now, if I look into my data set, so you will be able to find out that somewhere my data set value is 5.1 or somewhere 3.5 and 4.7 and all those things. And now I have a multiple columns as well. I have a multiple columns in this particular place. So how my plot looks like. So basically, so I have a multiple columns over here, and I have like many things over here. I have many things in this particular place, many data set I have. So what it try to do is, so it will always try to take a minimum and it is going to take a maximum. It is going to take a minimum and a maximum of all of those data sets, and then in between that it try to create a default scale. Even you can try to create your own scale, that is also a flexibility which is available, but it will try to create a scale based on the minimum and the maximum for all the numerical value. As of now, it will not be able to plot any kind of a categorical column. There is a way by which you will be able to plot even a categorical data. I will talk about that as well, how to plot a categorical data. But as of now, so by default, it will automatically take all the numerical values. So like we talked about a describe. So by default, describe always takes a numerical value into a pandas data frame. Similar way, similar situation we are facing over here. Similarly, so it will try to take like all the numerical columns which is available in this particular place, and then it will try to plot all the numerical values, all the numerical data set. So as you can see in a y-axis, so it is trying to take a range of 0 to 8. Now if you will go and if you will check a minimum and the maximum data set, so you will be able to find out that some minimum data set and some maximum data set. So maximum wise, so minimum to maximum, you will be able to find out all the data set in that range. That is one thing. Now the second thing is, so in my data set, so I had basically 4 columns. So what it will try to do is it will try to draw this column with indexes. Then it will try to plot this column with indexes. Then what it will do? So it will try to plot this column with indexes. Then what it will do? It will try to plot, I would say, it will try to plot like this column with indexes. Because in x-axis, I already have a indexes. In y-axis, so I have all the data range, basically. So all the data range that I have in this particular place. So it will try to plot each and every data set. So combination of a index plus data, index plus data, index plus data, index plus data. It is going to plot. This is what you will be able to observe in our first line plot that we are trying to do. So you will be able to find out over here. Okay, let me reduce our figure size. I think it will be better for me to explain you. So here maybe I can try to make like a 8x8. Yeah, and even in this way, so maybe I can try to give this as a 15. Okay, like 15 cross maybe 6. Yeah, now it's fine. So maybe I can try to make it more small. So 4, let's suppose. Okay, now it's fine. So here you will be able to find out that, okay, so this is the graph which I'm able to get. And I had like a sepal length, sepal width, petal length, petal width. Now, if you will start studying this graph, if you will start studying this data set, so you will be able to find out some of the features. So here we have a red line, we have a green line, we have an orange line, we have a blue line. We have a 4 columns, sepal length, sepal width, petal length, petal width. Like I told you, categorical data set, it will not be able to plot. So species column, you will not be able to see over here. You will be able to see just 4 numerical column. Now, so here you will be able to see that a red line is representing petal width, green line is representing petal length, orange line is representing sepal width, and blue line is representing sepal length. So fine, it will automatically create a notation for you. Even you're not supposed to worry about that. This is how beautiful this library is. Now, so here a red line is representing what? It's a petal width. Now, if I'll ask you a question that, okay, so tell me in what range to what range your petal length of a particular species was fluctuating, right? If I'll ask you that in between what range to what range your petal length is fluctuating, you will be able to give me an answer. So you can say, tell me that, okay, fine, so your petal length was fluctuating in between maybe this to this point. So this to this point. So minimum petal length was almost close to 0 and maximum was almost close to 1.5. This is what, because this is the fluctuation you are able to get. This is the fluctuation you are able to get with respect to all the petal length across all the data set, all the 150 data set that I have, 150 records that I have. So across all the data set, this is the fluctuation that you will be able to get. Now, if I'll ask you that, okay, fine. So what is a fluctuation of the petal length? This was for the petal width. Red one was the petal width. So for petal length, which is represented by green color. So you can tell me that, okay, fine. So petal length is fluctuating. I can say, so this petal length is fluctuating starting from like a 1 point something till till around 6 to 7. So I have some flowers. I have some flowers which is having a petal length from starting from 1, and petal length is going till maybe a 6. So this is the kind of understanding that you will be able to get just by looking into this graph. Similarly, you will be able to do some kind of observation with respect to all the other columns as well, that from what range to what range my data set is fluctuating. And then like okay, so if I'll ask you, okay, tell me like first about something about first 45 flower. So you can say that, okay, fine, so in first 45 flowers, so I have not I was like I was not able to get any fluctuation or much fluctuation. So almost like petal width was almost same, again like a petal length was almost same, sepal width was almost same, and sepal length was almost same. But after that, so we are able to see lots and lots of variations. So maybe like you have plugged all of those flowers maybe from some of the fields, and then other flowers from some other fields, and maybe because of that, so you are trying to observe this kind of a fluctuation possible. There are lots of different kind of a thoughts that we can generate just by looking into this kind of a data set. So this is basically like this is going to give you some kind of insights, although our data set was very small and it's not that significant data, but still I'm able to get some kind of a understanding about the data set just by looking into this graph. So this is how it happens whenever we talk about graph representation. Now, so apart from a graph representation, so graph wise, a default graph was a line graph. Apart from that, so what I can do is I can try to create a bar plot as well. If I wanted to create some other kind of a graph, I can do that. So I can try to go ahead and I can try to create a bar plot. So here, like data frame dot plot, and then you can try to call a bar plot. And bar plot wise, so this picture will not be that much clear. I'll talk about a bar plot over here. So here I'm trying to call iris dot drop. And I think we know what is the meaning of drop. So drop, always try to drop a particular column on a particular axis, or rows on an axis. So here I'm trying to call data frame, iris data frame dot drop. Drop what? So drop my species column. So the last column I wanted to drop it. So fine, it will be able to drop it on an axis 1. So axis 1 means on a column level. Axis 1 means column, as simple as that. So it's completely fine. I'm trying to drop it basically, and then I'm trying to create a data frame. And after doing that, so I'm trying to call data frame dot ilog. I think we talked about ilog in our data frame class, in our pandas class. So data frame dot ilog, I'm trying to pass 0 over here. So it will try to select a 0th row. So fine, this was my data frame. So data frame dot and GAD head. So this is my data frame. I'm trying to select a 0th row. So I'm trying to call like a data frame dot ilog and then 0, and then sepal length, sepal width, petal length, petal width. I'm trying to select in this particular place. Sepal length, sepal width, petal length, petal width. I'm trying to select in this particular place. Now, so what I'm trying to do is, so this ilog, so whatever like a first row data set that we have captured, this first row data set that we have captured. So I'm trying to plot it. I'm trying to plot this data set. So I'm trying up and plot wise bar plot. So here you will be able to find out that I have, so if I'll try to show you a nature of this data, so if I'll try to check the type, so for sure it is going to give me a series. For sure it is going to give me series. So yes, it is a series that I'm able to get. So I'm trying to plot only first entire row, and that too like with respect to a name, with respect to a categorical data. Fine, I'm going to call a bar plot. And I wanted to know that, okay, so what is like a comparison of a sepal width, sepal length, petal width, and the petal length that we are trying to create over here. So it's completely fine. Kind is equal to bar, sepal length, sepal width, petal width, right? So we are going to create. So sepal length wise, so whatever sepal length that we have, whatever petal length we have, whatever sepal width and petal width that we have, so it is just trying to represent. Now, so if you will look into the data and then if you will try to look into the graph, I think you will be able to understand everything very clearly. So here, this is my data. My index was sepal length, sepal width, petal width, because I'm trying to select only one row. So for sure, like it will be a series, and my data set is this one. So sepal length. Now, what is the value? 5.1. So yes, on a x-axis, so I'm able to see the indexes. I'm able to see all the indexes on a x-axis. On a y-axis, I'm trying to see the magnitude. So here I'm able to see all the magnitude in this particular place. So it's a 5.1, and then like a 3.5 I have, and then like a 1.4 I have, and then 0.2 I have in this particular place. So this is how you will be able to create a bar plot. So bar plot simply means that, so in an x-axis you can try to give any kind of a range or any kind of a specific indexes, and on a y-axis, so you will be able to create basically like on an x-axis you will be able to give the ranges. Now, so if I look back into the first case, so even I can try to call a bar plot over here, and I will be able to get the data set. I will be able to get a graph. So here in this one, so maybe I can try to set figure size, and then I can try to set like a bar. And this is how this bar will look like. So just wait for some time, you will be able to get that. So see, there is a bar which I'm able to plot it. It's very simple, right? So I'm able to plot a bar with respect to all the dates. Now we have like 1,000 dates, and that's the reason. So all the dates are not visible. Just try to look closely on your x-axis. You will be able to find out that yes, everything is visible. Everything I'm able to plot in this particular place. Or else what I can do is I can try to reduce the value into a data frame. Maybe I can try to take maybe like just 10, and period wise I can try to minimize that as a 10. Now if I'll try to plot it, so you will be able to see a very clear bar over here. So this is the bar that you will be able to find out. Let me change the, it should be 5 cross 5 so that it will be visible in your screen. So as you can see, so I'm able to see all the bars basically. So bar means, so on a x-axis it is trying to represent the indexes, on a y-axis it is trying to represent the magnitude. So this is a bar plot that I will end up creating. That is completely like a fine. So I'm able to create a bar plot, I'm able to create a line plot. Fine. So now bar plot is completely fine. So we are able to create it. Now, so I'm trying to load another data set over here, which is again another famous data set, which is called as a Titanic. So you can go to Google and then you can try to download it, because even you will be able to get a CSV format of the data set, and you can try to import it. I think we all know how to import a CSV data set, or else, so this data set is already available into a Seaborn packages. You can load it even from there. So here I'm trying to load it from the Seaborn. So fine, let's try to understand it. So I'm trying to call like a sms.load dataset, and this time Titanic. So I'm trying to load this dataset. All these things are available into a data frame. Now inside this we have a multiple rows and multiple columns. Now here what I'm going to do is I'm going to call like a passenger class. I'm going to select only one column, passenger class column. So I have a passenger class column, and in this passenger class column you will be able to find out three values: class 1, class 2, and class 3. So here data frame, and out of that, so I'm trying to select a column, and then I'm trying to call a plot, and kind is equal to bar. So I'm trying to call like a bar plot over here. As you can see, data set is a two hues. That's the reason. So on a y-axis you are able to see all this black kind of things, because there are like so many things it is trying to represent in a very small space. That's the reason it's a complete black. You are not able to see everything like visible, and that's the reason. So like we can go ahead and we can opt for some other kind of graphs, that is possible. But yeah, if I'm going to show you a bar plot, so bar plot wise, so if I have a column, simple, indexes will be the x-axis and the value will be the y-axis, and you will be able to see all the data in three steps: 1, 2, 3. Because in my passenger class I had three kind of class, I had three kind of magnitude: 1, 2, and 3. And yes, I'm able to see all of those things. Now here, let's try to understand it. So I'm trying to call like a pandas.data frame, and then so I'm trying to create a data frame basically of size 10 cross 4. NumPy kind of a things you can say. So even in NumPy, so I was trying to create like a matrices. So here I'm trying to create like a pandas.data frame, and a 10 rows, 4 columns I'm trying to create. I'm trying to give a column name over here, as you can see, and then I'm trying to call like a data frame dot head. So it is just showing you some data set over here. It's a random data set which I've created. Now, so I can try to call data frame dot plot dot bar. So last time you must have seen that I'm trying to pass argument as a bar. This is also fine. or else bar as a function, which is also available. So you can call as a function or as an argument. In both the way, you will be able to get a final outcome. Now, if I'll try to explain you this data set, so how I will be able to explain you? Let's see like how this looks like actually, so that you will be able to get a complete insights. So here, representation wise, so you will be able to find out that we have many data set that we have created, basically like a 10 rows we have created, and then we have a 4 column that we have created. That is fine. Now, if I'll talk about a first row, so basically, like I told you, indexes will be represented on a x-axis. So indexes will be represented on a x-axis, and then this column value or column will be represented on a y-axis. This will be represented on a y-axis. So we have basically like a x-axis and we have a y-axis. Now, so for row 0, if I'll talk about a row 0, so we have, for row 0, we have 4 values, A, B, C, and D. That's the reason. So you will be able to find out 4 line over here, blue, orange, green, and red. So A, what is the value of A? 0.58. You will be able to see that value of blue is 0.58, value of B is 0.73. So value of like a B is 0.73. So value of orange is 0.73. You will be able to find out. Value of green is 0.77. So yes, it's almost same, 0.77. And then value of D is equal to 0.91. So you will be able to find out value of D is equal to 0.91. So we have like this data. We have this data and row by row. So this is representing one row. This is again representing another row. This is again representing another row. This is again representing another row. So that this is what you will be able to find out. Row number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the things which it is trying to represent over here. These are the things which it is trying to represent over here. It's very simple. It's very intuitive, I would say. So like just by looking into this data, you will be able to tell me many kind of different things. Like if I'll ask you that, okay, fine. So in what range to what range my B column is fluctuating? My B column is fluctuating. Now, what is the representation of B column? So B column is represented by a orange color over here. So you will be able to find out that, okay, so orange color is fluctuating from somewhere minus 0.7 to somewhere over here. So in between this to this range, my B column is fluctuating. I will be able to give an answer very easily just by looking into a data set, or like just by looking into this graph. So I will be able to find out these things. So this is how intuitive this thing is. And again, so if I have this kind of a numerical data set, so I will be able to represent in this particular way. Again, similarly, so like if I'll talk about a NumPy, so again, in the similar way, you will be able to represent NumPy arrays as well, because what I have done, I have just created a random function I have taken, and random function, we know that it is going to give me a NumPy matrices, and just trying to convert those things into a data frame. So this is how like you will be able to create one kind of a graph. Likewise, we have many kind of a graph that we'll try to understand. Now, so here I'm trying to call bar as a method. Here I'm trying to call bar as a argument. Both the cases, it's completely fine. It is going to give you a same result. Now, if I wanted to flip my bar graph, so simple, there is a bar H which is available. So bar horizontal, it is nothing but kind of a transpose operation. So it is just going to rotate. It is just going to rotate your entire graph. This is what it does. So fine, bar H. So it's completely fine. It is able to like perform these graphical operations in the horizontal way. Now, so here, so we have seen a line graph and we have seen a bar graph. This is the two kind of a graph that we have seen. Line graph simply means that again, like an index on x-axis, and then on y-axis, magnitude or variations you can say. In bar graph, same thing happens. On an x-axis, there will be indexes, and in a y-axis, so there will be a magnitude which is trying to represent. Now, so there is another kind of a graph which is available, that is called as a histogram graph basically. So here we are trying to call iris.plot.histogram. Now, what is a meaning of a histogram? So in histogram, what happens is, so in your x-axis, it is going to show you a range, and then in y-axis it is going to represent a frequency. In your statistics class, I will be talking about a normal distribution and all those things. You will be able to find out that we can try to plot a normal distribution curve even with the help of histogram. So let's try to understand that what is the meaning of histogram over here. So fine. So here you will be able to find out that I'm trying to call iris.plot.histogram. And what is iris? So iris is nothing but iris is a data frame that we have. So iris.head head, and then I can try to plot 5. So fine, this is the iris data frame that data set that we have. Again, we know that, okay, like these are the 4 columns that we have created. Now, if I'm going to call a histogram on top of that, so you will be able to find out that it is representing a sepal length, sepal width, petal length, petal width. So it is representing almost all the columns except a species column because it is having a categorical data. So it is trying to represent. Now, if I'm trying to plot a special graph called as histogram, so in this graph, you will be able to find out that it represents a range on a x-axis, and then magnitude or frequency on a, not a magnitude, frequency on a y-axis. Now, what is the meaning of that? So red is representing petal width. So Z is representing petal width over here. I can have a data set in between any range to any range. Now, so if I am going to ask you a question that what is the data set that you have where petal length was in between 0 to 1. If I'll ask you this question, that what is the data set that you have where petal length was in between 0 to 1? How many data set that you have? So you can answer me this question just by plotting a histogram. You can tell me that, okay, fine, so in between 0 to 1, so you basically had almost 50 data set. Now, in between like 1 to 2, I was almost having like a 55, 58 data set, and in between maybe like 2 to 3 or somewhat here. So I was having these many number of the data sets. So histogram always talks about the frequency. It never talks about the magnitude. So in an x-axis, it takes a range, and then in y-axis, it always talks about that frequency of the distribution. Now, if I'll ask you that what is like orange is represented by sepal width. So for sepal width, we are representing with the help of orange. So here you will be able to, if I'll ask you a question that what is the number of the total flower that you have where sepal width was in between 2 to 3, you can tell me that, okay, fine, so almost close to 100 flower that I had. So where sepal width was in between 2 to 3. So this is what you will be able to get from a histogram, and this is what we are trying to call over here. So you can try to provide histogram as a parameter, or you can try to call the method as well. In both the cases, you will be able to get your answer. So fine, this is like how we can, again, histogram is a very important graph. So you will we'll keep on creating this histogram many times going forward. Now here, so iris.plot kind is equal to histogram, stacked is equal to false. Now stacked could be true, it could be false. Now what is the meaning of stacked is equal to true and stacked is equal to false? So let's try to understand it. So here, if I'm going to make that as a true, so you will be able to find out that there is an overlap. So generally what happens is, suppose if your frequency is small, so it will try to hide it behind the graph. But if you are going to make stacked is equal to false, but if you are going to make a stacked is equal to true, you will be able to see that all the graph came because there is a multiple column that we are trying to plot, multiple columns we are trying to plot over here in a single graph itself. If you are plotting one column at a time, that is completely fine, no problem with that. But if you are trying to plot multiple column at a time, so for sure there could be a same range of a data which exists for one column and it exists for other column as well. And in that way, so if you are going to make a stack is equal to true, so it will try to bring all the smaller graph in a forward front, and then all the graph with the a bigger length in a back side, so that both the graphs will be visible. So this is what a stack is equal to true does. Now if I'm going to make a stack is equal to false, so again that is completely fine. So you will be able to get this kind of things. Now if I'll talk about our bins, So bins is nothing but, so it always try to help you out to control a width of the graph. So its bins is like a small. In that case, it will be having like a wider graphs. And then if I'm going to keep bins is equal to like a very high, in that case, so it will try to give you a very thin graph. So as you can see, like a very thin line, it is going to give it to you. So this is how you will be able to control even the width of those graphs that it is going to plot. Now here, so again, I'm trying to perform the same thing. The only things which I have changed over here is, so I'm trying to change the orientation, and here it is. So orientation means, so I'm just trying to change orientation as equal to horizontal, and it is trying to flip my graph. So I can try to use histogram horizontal. I can try to plot histogram vertical. By default, it will be histogram vertical, but yes, I can try to plot histogram horizontal as well, and that is also possible. And yes, I'm able to do that. So guys, this is completely fine. So we have discussed three graphs so far so good. So one is basically like a line graph, other one is a bar graph, and the third one is a histogram. Now, so I think we all know what is the difference between a histogram or like a, or what is the difference between a bar graph or a line graph. Now here, so I'm trying to create a data set. I'm trying to create a data set, and then I'm trying to plot the histogram. So just for one column, only for one column. So I'm trying to perform the histogram operation. So here, kind is equal to hist, which I have given over here. So on a x-axis, so you will be able to find out that on a x-axis, this time I don't have a indexes. In case of a histogram, I don't have an indexes. I basically have a range. As we have already discussed, that histogram is a different kind of a graph. In a x-axis, it always try to take the ranges. On a y-axis, it will try to give you the frequency in between that particular indexes. So in that particular range, I would say range of the data. So it's completely fine. You will be able to find out that in a x-axis, it is trying to represent the it is trying to represent the ranges, and in a y-axis, so it is trying to represent the frequency in between those ranges. So guys, yeah, it's completely fine. So we are able to plot a histogram. So suppose if I have asked you that, okay, fine, so try to perform a group by operation, and for every group, so give me a count of these things. You can go ahead with the histogram, you can try to plot it, and I think you will be able to get your answer. Now, so I'm trying to perform the similar kind of operation as you can see over here. So I'm trying to create a data frame, and I'm trying to drop a species column, which was nothing but the fourth one. So remaining will be like a sepal length, sepal width, petal length, and petal width column. So find sepal and sepal width, petal and petal width column that we have over here. Now, so here I'm trying to call like a data frame dot differences and a histogram. Color is equal to blue, alpha is equal to 0.1, figure size is equal to 10 cross 10. Now, so if I'm going to call histogram on this one, so let's try to do that. So here you will be able to find out that for all the four different columns, it has created a different kind of a it has created four graphs. You will be able to find out that it has created basically a four graphs for us. Now, so if I'm going to remove this one, you will be able to find out. So it's completely fine. It has created this one. Color is equal to blue, which I have opted for. I can try to opt for maybe a red color, maybe a green color. That is completely fine. And alpha is nothing but it is trying to control the intensity of the color. If I'm going to keep 0.9, you will be able to see it's very dark. And if I'm going to keep 5, so you will be able to see it will be like a in between. So alpha is nothing but just trying to control the intensity. Figure size is nothing but the total figure size. Now here, so it has created four graphs because we had how many columns? We had a four columns by default. In any other graph, so it was trying to just overlap it. It was trying to overlap all the columns, but here, so it is trying to like create basically like a four different like a graphs in this particular place. And again, concept is exactly same. So in an x-axis, you will not be able to find indexes. You will be able to find basically a ranges over here in case of a histogram. So if I'll ask you a question that, okay, so in a petal length in between 5 to what is the number of the flower that we have inside our data set, which was having a petal length in between 5 to 6. So you can tell me this, you can give me this answer very easily and very clearly that, okay, so there was almost this many number of the flower that you had where petal length was in between 5 to 6, or maybe if I'll ask you 1 to 1 or 1.5, so you can tell me that, okay, fine. So there are almost close to 3738 data set that you have where, so you are having like petal length is equal to in between 1 to 1.5. This is like how you can create a histogram, and this is how you will be able to get your answer. So fine. So yes, I think we are well aware about the histogram. Now here, so let's talk about a scatter plot. So how you will be able to create another kind of a graph, which is called as a scatter plot. Scatter plot is nothing but dots, all the dots. And we know that like to plot a dot, we need a x coordinate, we need a y coordinate, because any dots in this 2D coordinate or maybe a 3D coordinate is represented by xy or xy or z. If I'll talk about a 3D, as simple as that. So here I'm trying to call data frame dot plot, and I'm trying to call basically a scatter plot. In a scatter plot, so you are supposed to define your x value, you are supposed to define your y value. Otherwise, this scatter plot is not possible at all. So it's completely fine. I'm trying to define, so data frame dot plot dot scatter, I'm trying to define x value as a sepal length and y value as a petal length. Suppose if I wanted to study, that, okay, so what is a relationship that we have in between a sepal length and the petal length inside my data set. If I wanted to study a relative, like a study, if I have to do between two columns, fine, I can make one as a x column, one as a x axis, another one as a y axis. So it's my custom x and y axis I'm trying to create over here. So if I'll try to plot it, so you will be able to find out that plotting wise, so sepal length is available in x-axis and petal length is available in a y-axis as per my expectation. And this is the trend that it is trying to showcase. So sepal length is increasing, so petal length is also increasing. That's the reason. So you are able to get this kind of a graph, this kind of a curve over here. So sepal length is increasing simultaneously, so petal length is also increasing in the same direction, and this is the final data set. This is the final graph that you will be able to access and you will be able to get. So it's very easy. Data frame dot plot dot scatter, x-axis, y-axis I have given, and then I am able to check the relative study. I am able to do a relative study in between a sepal length and the sepal width. Now, so there is another factor which I wanted to include over here. So I have passed my x-axis value, I have passed my y-axis value. Now I'm trying to include another axis into this one. Now, what is the meaning of it? And many of you will get confused for sure in this one. So just try to like pay your attention for some time. It will be clear. It will be clear. It's not that tough at all. So here you will be able to find out that I'm trying to perform this scatter plot. So data frame dot plot dot scatter, and I have given my x-axis, I have given my y-axis in this particular place. So fine, I have given my x-axis and I have given my y-axis in this particular place. Now C is something that we have given in this particular place, which is a sepal width. So fine, I have given my sepal length. So I have given my sepal length as x, and then petal length as y, and then sepal width as c. This is what I have done. Sepal petal length as. So scatter plot wise, you will be able to find out same graph as we have seen in last graph. So you will be able to find out same thing. It's a relative study in between x and y. Now, what is the contribution of C over here? So in C, you will be able to find out that we have certain data set. Now I try to create the scale. It tried to create the scale. This is a C. This is a C. Contrast it has created. Now contrast wise, you will be able to find out that it has created this scale based on the range of the data which is available in between this sepal width. So in sepal width column, we have a data set starting from 2 to this one. So starting from 2 to this one. So this is something data set that we have available. So it will try to create the contrast scale, and it will try to, as you can see, like it is starting from the very light and then going till dark. As the value will increase, it will go till dark. So if you will try to understand this particular graph, so you will be able to find out in this way. So 3.5. So 3.5 will be here. 3.5 will be here. And for 3.5 scale, so what is a sepal length and what is a petal length? Sepal length is 5.1 and petal length is 1.4. So 1.4 and 5.1. So 5.1 will be somewhere over here, 1.4 will be somewhere over here, let's suppose. So what will be the color of this one? What is the color of this dot? So color of this dot will be equal to this color. So I have a contrast column which I have introduced, which will try to control the color, because with respect to 5.1 and 1.4 we had this 3.5. I'm just trying to control the contrast, as simple as that. Now, so again, if I'll talk about other data sets, so yes, wherever we have this and this combination, so contrast will be this one. Simple. Whenever we have this and this combination, contrast will be this one. So that's the reason. So you will be able to find out all the dots with the different kind of a sets, because based on their relative or relevant sepal width, so it is trying to give you the color. But here color was completely equivalent, because here I have not introduced any kind of a contrast column. But here, so in case of a contrast column, yes, this is what you will be able to observe, as simple as that. So I think I'm trying to do the same thing. Yes, petal label is equal to length. Fine. So here I'm just trying to give label is equal to length. So again, it's the same thing. Now, so let's try to observe over here. So I'm trying to call data frame dot plot dot scatter. I have given x-axis, I have given y-axis, I have given contrast column as well. So contrast column I have given, and then size. S means size. So what will be the size of your bubbles or dots, whatever like you are trying to create, that is completely fine. So size is equal to 190. You can try to control it by like increasing or decreasing your sizes. Not a matter at all. Now, so here again, I'm trying to plot a graph. So this time I'm trying to plot hexabin. So last time I was trying to plot the scatter plot. So it will try to create a round circles. Simple. Hexabin means it is going to, instead of giving a circle, there will be a hexabin it is going to create. As simple as that. So hexabin, x-axis, y-axis value I have given. Grid size is equal to 5 I have given. So it's completely fine. I'm just trying to define the windows size. A grid size means like a size of this hexabins. If you wanted to control it, you can control that as well. And then C is nothing but a contrast column which I have created over here. So let's suppose grid size is equal to 50, which I'm trying to give. So as you can see, now it's become small. If I'm going to like keep it as a maybe 10, so you will be able to find out that yes, this is the size that you will be able to find out. So here, based on the hexabin, so this is almost equivalent to a scatter plot. There is no differences. You will be able to find out. The only thing is like a representation. This is why where you will be able to find out little bit of differences. Now the next one. So we have seen basically line plot. We have seen, I would say, like a bar plot. We have seen a histogram. We have seen a scatter plot. We have seen a hexabin plot. Now the next plot that we are going to talk about is basically a pie plot. Pie plot is nothing but pie chart. I think most of us has done this kind of things in our childhood as well. So just a circle, and then based on that we try to divide the area and everything. So here we have a sepal length, sepal width, petal length, and petal width. As simple as that. Now I'm trying to call this data. So this is the data set that we have. Data.plot what plot? Pie plot, and then figure size 10 cross 10. So you can give 5 cross 5, 10 cross 10, doesn't matter at all. So here we have like 4 indexes, index wise sepal length, sepal width, petal length, and petal width. And these are the data set. These are the total data set that we have. Now what will happen over here? So it will try to do 5.1 plus 3.5 plus 1.4 plus 0.2. Now, so what is area it is going to allocate to sepal length? So this is the area 5.1. Let's suppose this is equal to M. So area allocation to like a sepal length is equal to 5.1 by M. Sepal width 3.5 divided by M. 1.4 divided by M. Petal width this one by this one. So this is just a percentile, I would say. So it is just trying to assign the percentile, the area. So fine, here you will be able to see that, okay, fine. So petal width is very less. Petal width is a very less. Yes, it is less even in terms of values. And rest of the data, sepal length is almost occupying half. So 5.1 you will be able to find out. So it's completely fine. Now what I'm trying to do is I'm trying to like call a data frame dot head dot t. This is my data frame. I have just transposed it. I have made this column into row into columns. That is completely fine. Now I'm trying to call like a data frame dot plot dot pie. Subplot is equal to true, means it can create a multiple like a pie plot. Figure size 20 cross 20. So in this case, you will be able to find out that it is trying to plot basically column 1, column 2, and a column 3 with respect to a sepal and sepal width, petal and petal width. So in one graph, sepal and sepal width, petal and petal width. Another graph, sepal and sepal width, petal and petal width. So wherever, like people used to like, you must have seen on news. So people used to say so lots of pie charts, pie graph, and all those things. I'm just doing the same thing. Now here, so I'm just trying to show you some parameter notation. Subplot is equal to true. So yes, like multiple plots is going to create. Figure size, total size of the windows. Auto pact is equal to 0.2 like percentile 0.2 f. So it is going to give you that, okay, so what is the total number of percentile it is going to occupy from what data set, and that too with the 2 dimension, like 2 decimal points. This is what it means. Again, this is like a same thing which I'm trying to plot now. So here I'm trying to do a scatter matrix plot. Now again, this is another kind of a plot you will be able to find out where, so suppose if I have to compare everything with everything. So if I'll talk about my data frame, so my data frame was having almost like a everything. Data frame was having sepal length, sepal width, petal length, and petal width. Now if I wanted to do a comparative study, so what I can do is I can try to basically like plot a scatter plot, and in this scatter plot you will be able to find like a scatter matrices. So you will be able to find out all column versus all column. So I had like 4 columns, sepal and sepal width, petal and petal width. So yes, I have a sepal and sepal width, petal and petal width, all column versus all column, and in a diagonal, so I have given a KDE plot. KDE is nothing but it's a normal distribution plot. So it's a comparison of the same column with the same column. So here you will be able to find out that I'm trying to compare sepal length with petal width, sepal length with petal length, sepal length with sepal width, sepal length with sepal length itself. So this is nothing but sepal length with sepal length. So it always try to compare by itself, and then like I try to perform the normal distribution. So it try to plot, it will always try to plot the normal distribution graph. This is the meaning of KD plot. Diagonal means KD I have given. So KD means kernel distribution. So it try to plot the kernel distribution over here, and it always try to like plot a normal distribution graph. And normal distribution graph wise, I think we'll talk about these things in very detail in your statistics class. Now, so sepal length versus a petal length. So you will be able to find out all the trend. Now, if I'll ask you that whether there is some relationship which exists in between petal length and the petal width or not. So in between a petal length and petal width, are you able to find out some relations? So petal length and the petal width, you can say that yes, there is a relation. There is some kind of a linear relation which I am able to find out. But if I'll ask you a question that are you able to find out some relationship between a petal length and the sepal width? This is the graph. This is the graph, and there is no relation. It's completely like a scatter graphs, and I'm not able to find out any kind of pattern. Even over here, I'm not able to find out any kind of pattern between sepal width and the sepal length. So if you are looking for like a complete analysis of the data set, a complete analysis of every column with respect to every column, so in that case you can try to call scatter matrices, and then it will be able to print and plot all of those kind of graphs for you. Now KD is nothing but KD is just a normal distribution graph, kernel density basically. Now so yeah, so there is something called as an Andrew curve. So Andrew curve is again another kind of a curve. So if you have to do it, then you can try to call from pandas, Andrew curve, and then you can try to pass a data frame over here. So Andrew curve is going to represent like, okay, this kind of a linear shape for every kind of a data set that you have inside this one. So again, so I have trying to give a sepal width, and it is trying to draw a Andrew curve for this sepal width column that we have inside this one. Again, it's barely used a data frame, like a plotting method, I would say. Now here, so I'm trying to call my data, and then I'm trying to do some styling. So styling wise, R dash dash. So this simply means that red dash dash. So it will try to represent all of those graph with dashed line. Otherwise, it will be a continuous line. But here, so you will be able to find out the dashed line. So again, it's a legend is equal to true. This is called as a legend. So legend is equal to true means it will try to show you a legend over here. So this is just for the, this is just being used for the styling. Styling wise, there are thousands of functions which is available, which you can use for the styling, I would say. Now log is equal to true, so it will try to show you like if you're going to make log is equal to true, in that case it will try to show you a logarithmic kind of a result in a y-axis. This is what it does. So again, it's same thing. Now let's try to talk about here. So as we have discussed about a subplot in our pie plot, so subplot is equal to true means, so it is going to plot all the columns into, it is going to plot, I would say, all the columns into a different rows, as you can see. So this is the meaning of a subplot. So if you wanted to see all the graphs into a different one, so yes, that is also possible, and you will be able to do it by calling subplot is equal to true, or else what you can do is, so subplot is equal to true, share x is equal to false. So share x, even if you're like forgetting about this parameter, it's completely fine. Layout is equal to 2 cross 3, so 2 row 3 column. So in this way, what will happen is it is going to create a boxes in 2 row and 3 columns. So in 1 column there will be like a 3 column we have created, so 2 row 3 column. So we have a 4 I can say like a 4 column that we have. So it is just trying to represent all the 4 column into a different boxes. This is simple. So, and plot is equal to tight layout. So tight layout means it is going to arrange it accordingly, and then it is going to show you all the data. So this is just been used for the representation purpose. So it depends, this is a part of a like a graph beautification. So it depends what kind of a graph you wanted to plot, and accordingly, so you will be able to do it. So again, like a geographical index graph, I'll talk about that, but yeah, so I think we can take some question, and then I will jump into a Seaborn, and then I will try to talk about Seaborn libraries. I think most of you must not be having any kind of a question. So those who is having any kind of a question, they can raise their hand and then they can talk about it. Yeah.
Hey, Sudhanshu.
Yeah, go ahead.
What is the difference when we say df.plot and we are passing the kind parameter inside?
There is no difference actually. So in both the way you can call it. So one by like using a method, or by passing out the parameter. Both are same.
So both are same. And can you come to the 59, in line number 59 in the last, I think?
Okay.
Not exactly. I mean, the last graph which you showed, the 4 different images.
This one.
Yeah, this one. So in this case, when we do df.plot, normally it displays the image, but here we have to explicitly tell that plot.tight and layout.
Why? Yes, yeah. So why means this is how this library has been designed. That's why, right?
No. I mean, before it was directly giving the plot, right? I mean, when we were doing df.plot, some other graphs before this.
Yes, yeah. So I think you haven't tried these things, right?
Yeah, I haven't tried. That's why I'm asking. But I'll always focus in the session and then try later.
Even if it is working without calling this tight plot, but if I'm going to call tight plot, so you'll be able to see that it's not printing the objects.
Okay.
See, look over here, right? We don't have anything. Now here we have an object and then graph, right?
Okay. So
fine. In case of a tight plot, it will remove all the objects and then it will try to print only the graphs. And tight plot means like beautification, right? It's just been used for the beautification, nothing else.
Okay, thank you.
Hi, Sudhanshu, Mundan here. So why do we need difference data from difference than we are plotting in some places? So what is the actual need for the difference data frame or difference method? Then we are
difference
plotting.
Is no, so there is I'm just trying to create my data set. So it's not like even if I'm not going to create a difference, so I will not be able to plot it. That's completely fine. I was just trying to show you one of the additional method over there. That's it.
Okay.
Yeah.
Hi, Sudhanshu. Can you tell me how to interpret hex bin plots? The hex bin plots, how to interpret them?
See, it's similar to your scatter plot, right? Are you able to interpret a scatter plot?
Yes.
See, it's the same. There is no difference in between a hex bin or a scatter plot except a representation, right? So if I'm going to keep grid size equal to maybe 100, now you will be able to. Is it same?
Yeah, right. Okay.
There is no differences. It's very simple.
Okay.
Can you Sudhanshu, you had given about the scatter matrix. So in scatter matrix, it is not taking the categorical data. So it is by default that it will take only the numerical part of the data, and it
it will always scatter plot or scatter matrices always takes the numerical values. It is not going to take a categorical value at all. Because numerical method is just trying to show you the relationship, right? So you can only be able to observe a relationship between the numerical data set. How you will be able to observe a relationship between the categorical? That is not possible, right? In terms of a scatter, because X and Y. So you will be able to observe those things in a histogram in another kind of plot, but not here. Yeah.
Okay.
So it's a normal in a scatter matrix. It shows a normal distribution, and the scatter plot it will always play plot like that, or
a scatter plot is just trying to plot a relationship between a x-axis and y-axis. A scatter matrices on a diagonal axis, so it is going to give you like a normal distribution. So because I have written over here like a KD plot, if I'm going to remove this KD, right? So then you will be, if I'm not going to take this KD, let's suppose, and then if I'm going to plot, so you will be able to find out histogram actually. So like I told you, histogram is basically a normal distribution. I'll try to explain you in a statistics class as well. So histogram is basically a normal distribution. Okay. It's the same thing that it has plotted in a KD plot. Yeah.
Okay. Yeah. Okay. When we are doing that df.plot and storing that in that.
Sorry. Yeah, next question, please. Yeah, go ahead.
As far as I know, we are using this whole visualization thing using pandas only. Is there any reason we are not doing the core matplotlib?
No, where we are doing with the help of pandas. Basically, we are using this method called as PLT, right? And I think you haven't checked from where we are trying to call a PLT.
I know. This the whole pandas thing. This visualization is built on top of the matplotlib.
Yeah.
But we haven't done the core matplotlib, isn't it? If I'm wrong, this correct.
Which one? What is the meaning of core matplotlib?
Yeah, sometimes we need to call like, let's say, by using like a plt.plot, and
are we not doing this? Are we not doing a plt.plot? So what is the meaning of core matplotlib? I'm not able to get that.
No, Sudhanshu, actually you are mentioning df.plot, right? Directly.
Yeah.
You are not using plt.plot, right? So that may be the doubt, I think.
Okay, so like you can use a plt.plot. I think I'm using a plt.plot in many places. So this is just a way of writing these things, right? So you can use a data frame.plot or plt.plot and then try to provide a data set. In both the ways, it is going to give you a same graph. Everywhere I'm going to use like okay, so plt.plot, plt.
In a matplotlib, if I remember, there is something called the axis. We can add an axis and we can add a figures thing.
We can add many things actually. We can add many things. We can add many figures, I would say. So like graph plot, pandas, plotly, couplings, geographical plotting, credit card, income data, insurance fraud. So there are many ways to do a data visualization. There won't.
I know. There is many ways, but
so
I'm just curious. I'm not complaining it. I'm just curious. Is it a core visualization based on matplotlib, or is it a pandas way to do it?
No, it's not a pandas visualization, I would say. I'm just trying to, I can say that, okay, fine, I'm trying to visualize a pandas data frame. So some data you need, right? So I'm, instead of using like some random data set, I'm trying to use some data frame. That's it. But if I'll talk about a method wise, so method wise everywhere. So I'm trying to use which method? I'm trying to use a plot, like a plot method belongs to basically a matplotlib, I would say. Like a core, if I'll talk about like a core plot method, so it always belongs to matplotlib, and yes, I am using those matplotlib.
So that means that you are using the pandas object over the object you are calling the PLT method.
Yes, you can say that. Yeah, go ahead.
Bar graphs are scatter plots. That point value or bar value, if you want to show, what is the option you can see?
Sorry?
In bar graphs or scatter plots, the data point value, suppose bar graphs is there, the bar graph value, if you want to show, what is the option there?
Which bar graph values you wanted to see?
In the bar graph or scatter plot, the data point value. Suppose scatter plot or bar graphs are there, right?
Yes, yeah.
Suppose bar graph, just go to the word bar graph.
Let me show you one example with PLT. I think that will be better.
And we have tooltips to see the values.
Yes, we have all those things to see the values. Google.
Sudhanshu, if there is any way I can share my screen and I can show you an example I have written here.
I have all the example. I'll show you. Don't worry. Just tell me what kind of example you are looking for.
No. What I mean is, if you confuse what I'm asking you, then I can share you the example here. Maybe you can make it clear.
I think he is asking for autopack types of thing in scatter graph and bar graph.
No. Each data point value. What is the value of the data point value? X-axis, Y-axis, the values are there, right?
The thing we're doing here is we just we're using data frame and we're just plotting directly on the top of the data frame using.
Suppose bar graph is there. Bar graph is there. On that bar graph, what is the bar value? It is showing legend displayed. The value of the bar. Suppose y-axis the value is 50. At the time 50 it should show on the bar graph like that.
I also had one question regarding the usage of directly plot API plot function on the data frame versus matplotlib.plot.
Go ahead.
So in 18 example 18 I see we are using matplotlib imported plt.plot. So
Okay.
is there any difference or functionality difference, like whether we want to use dataframe.plot or matplotlib.plot? Is there any
no, there is no differences. You can use any of these things. Both are same actually.
Okay.
So the whole idea and objective is to plot a graph, right? So it doesn't matter what kind of graph that you are going to, what kind of a library that you are going to use. Again, I'll show you a Seaborn. You will be able to find out that both are like almost similar, and then there is no differences. You will be able to tell me over there. So
I have a question regarding histogram.
Yeah.
Basically, it is the plot. It plots frequency.
Okay.
And frequency is related to time, but in Iris dataset there is no column related to time. So, what frequency it was plotting in histogram?
Frequency wise, it try to like pick and choose a distribution by itself. Okay, so I'm also talking about this one, right? So if I wanted to know point values, right? So I think just by looking into this graph, so this is what you're looking for.
Yeah, not legend wise in the graph itself, the point itself.
Okay, fine. In a graph itself, so if you wanted to see a point, so for that, so the best graph that you will be able to plot over here is a plotly. So because basically like there is in matplotlib, so it's a kind of a static graph. You will not be able to get a point wise. If you will try to hover your mouse over the graph, you will not be able to see the point. That's the reason. So in my course, so I have included one thing called as a plotly and cufflinks, and now you will be able to see all those things. Sometime it takes time to like plot this graph or print this graph. Just wait for another 1 minute because it takes time. DF is not defined. Are you talking about this?
Yeah.
Point?
Yes,
right?
Yes.
So this is what happens into a plotly. I'll show you like a simple
same in the bar graph itself. What is the bar value on the y-axis value?
Everything you will be able to get, sir. So I'll talk about these things. Don't worry.
Okay.
I'm going to talk about a plotly, right? So in plotly, so everything is available. So like you will just try to hover your mouse and
there is a limitation.
Yeah, matplotlib, there is a limitation. You will not be able to see all those things. Even in Seaborn, you will not be able to see all those things. You will be able to see these things just in terms of a, I can say like a no module folium. Remove it. Yeah, so you will be able to see all of those things in a matplotlib and all those things like a Seaborn in terms of a legends. But if I'm talking about if I'm talking about this plot, this one now, as you can see, this is value that you're looking for, right?
Yes, yes.
Point values. So this is
Yeah.
possible over here. And again, so there is not much differences. So it's the same graph, same data I'm trying to plot into matplotlib. See, plt.plot and data frame. Now people were asking about like why I'm not using directly a matplotlib. Here, so I can say that I can I'm directly using a matplotlib function, right? Matplotlib function dot plot, and then inside that I'm trying to plot data frames, right? I'm not saying data frame dot plot, right? I think like some of you were asking this question. And here, so I'm able to create just a static graph, but same graph I'm trying to plot over here, and same graph I'm trying to plot into a much more interactive way. Now, so whether it's a bar plot or whether it's a scatter plot, so everything like I'm trying to plot over here. So again, this is the bar plot, and see, this is the bar graph, like a female, 111. So I'm able to get the values.
So suppose male or female is there, right? On the top of
everything I'm able to plot, everything I'm able to see, bar plot, bar horizontal, this one, quartile values, all those values I'm able to see. Again, if I'll show you a 3D plot, so you will be able to get that as well. So even 3D plot is possible. So as you can see, like a X, Y, Z and all those things I'm able to plot in this area, right? So this kind of things are possible, but yes, matplotlib is having certain kind of a limitation. Matplotlib is not that good with respect to in plotting interactive graphs, and that's the reason. So you should know about a matplotlib as well as you should know about a plotly and couplings. And generally, like I recommend people to learn matplotlib and Seaborn, but whenever you're trying to plot some graph or like a production grade things, so in that case, go ahead with the plotly. So we'll try to cover these things in this section, not in matplotlib and Seaborn. So am I able to answer your question? A person who was asking a question that how we can get a data or see the values when I'm trying to hold my mouse for all the points. Plus a person who was asking a question that why can't I use directly like matplotlib API itself? Why I'm using like a data frame and then this one. So I can use that API. I don't have any issue. The only thing is, either way it's fine. You can call data frame.plot and then you can plot it, or else like a PLT, which is like a object of your matplotlib, and then you can try to call these things. Either way, this is going to give you same graph itself. So you should decide which way you want it to call. As simple as that.
So don't you one doubt last actually.
Yeah.
This is about saving the images.
Saving wise is simple. You can try to call a figure size and then you can try to call a save function. You will be able to save your graph. So that is also like very easy. Matplotlib save. So I'll just show you one example how to save a graph, and you can try to save it again in the similar way. You can save it anything. Again, plotly also you will be able to like save. You will be able to save a graph. That is also possible basically.
But it should be in a different format, right? For example, it has a live graph, right? So
live means plotly. If you will try to save, there is a different way by which you will be able to save plotly graphs. And many people who has participated into a chatbot challenge, they have done that. So they are doing that. So suppose this is the graph that we have, right? And suppose like if I wanted to save this graph, so it's very simple. So you can try to save in terms of a PDF or in terms of a PNG or in terms of anything. So as you can see, so like this is the graph that we have, and finally I have called plt.savefigure, right? And save figure wise, I have just given this name. Now, if I'll go to my specific directory, so I will be able to find out this name, and with this name, I will be able to find out a PDF. Now, in a JPG, in PNG, whatever formats I wanted to save, I will be able to save it. So let me show you this. So it's completely fine. Downloads and then line plot. I think this is the graph that we have plotted, right? And we are able to.
Can you share some examples like where?
Yeah, so this is the graph that we have plotted, and like we are able to save it, right? We are able to see it. Now, so not only in this format, you can save it in any format. So if you wanted to save it into JPG, PNG, just change these things. You can give a location / name. So in that particular location, it will be able to save it. This is just a small things. So everything is like just available on a single search, whatever I can think of. Yeah, so I can save all the graph that I've created. Okay.
Okay, thank you.
Yeah.
My
So
question is,
yeah.
once we are running the ML models and we are having the data, we have the training set and everything. So how do we? I mean, is it going to be how we are going to use these charts? Is it because one is that you have a static report saying this is the trend?
Ma'am, when we'll talk about the machine learning, I think it will be better. Then we'll talk about this, right?
Okay.
Yeah.
Sudhanshu, you have plotted some plots without those were in the red colors in the grids. You actually haven't specified subplots equal to 2, but they were, plotted in different, altogether different plots. So can you tell me how that happened?
Which one?
Hello?
Here?
You haven't used the subplots equal to true in that.
Which one?
Here?
I think here I have used subplot is equal to true.
No,
here
no,
also I have used subplot is equal to
Sudhanshu,
true.
it was in case of histogram actually. So when we were
Okay, in case of a histogram, you're not supposed to do that because like in histogram, so it will try to overlap it. If you're trying to like, okay, so I remember this one. I think you are talking about this case. You're talking about this case, right?
Yeah, this one.
HAST. Okay, fine. So let's try to compare. Let's try to compare this one and the histogram that we have done before. So here, so we are trying to perform the histogram. So again, here we are trying to perform the histogram like a data frame dot plot, and then we are trying to provide histogram as an argument. Now here, so we are trying to call this histogram as a method or function, I can say. So if you're going to call this as a function or method, so this is how it is going to represent. So by default, so it is trying to call yeah, so by default, it is going to create that many number of the graphs, and it will try to do that. When you are trying to create like when you are trying to call histogram as arguments, so in that case, yes, it is trying to give you a graph which is a overlap of everything.
Hello, Sudhanshu. I was asking like, hello.
Sudhanshu, can we plot the linear regression model?
Yes, sir. You can plot integration model. Have you tried it? No, right?
No, I haven't
Great.
tried. So I was just thinking about, can we plot in 3D manner, like we have all coefficients?
We can plot in every manner. I think we'll talk about this when we'll talk about a machine learning algorithm, right? This is not the time to talk about those things.
Sudhanshu, so
putting everyone on mute.
Explain the
I think people will start asking this, all the unrelated questions that they have received from somewhere else. So it's better to go ahead with the curriculum. This is what happens when I mute people. Okay, next graph that we are going to discuss about is a Seaborn. So let's try to talk about Seaborn. C-A-B-O-R-N. Okay, Seaborn. So Seaborn is again another packages that you will be able to find out, where again it will try to help you out to control lots and lots of visualization, and then you will be able to plot a different kind of data, different kind of graphs, and all those things. So it's almost equivalent to Matplotlib, but Seaborn is another library itself, and we can say that Seaborn is a powerful library, one of the most powerful libraries in terms of static data plotting, whether it's a 2D or whether it's a 3D. So whatever you can do in Matplotlib, everything you can do into a Seaborn. Again, Seaborn gives you a control over many things. You will be able to find out in which is not available into a Matplotlib. So fine, let's try to understand it. So here I'm trying to call all those things, and Seaborn set style is equal to dark grid. So style is nothing but the background. The background, if you wanted to set as a dark grid or maybe some other kind of a background, so you can just try to set it. There won't be an issue. Now, if you wanted to know what and all the styles are available, so I think you will be able to know all the styles which is like available. So we can try to just do one search over Google that style available into a Seaborn style in. It will try to give you all those stylings from Seaborn itself. So controlling configuration, go to official page of a Seaborn. Style is equal to text, style is equal to different kind of styles you will be able to get. Style is nothing but just a background. I'm using a dark grid. You can go ahead with the white, you can go ahead with the like a text, you can go ahead with the white grid. There won't be an issue. So just a background it is going to change. That's it, nothing else. So it's completely fine. These are the list of the styles which you will be able to find out. So I'm using just a style as a dark grid in this particular case. So the background will be dark grid in this case. Now I'm trying to load a data set called as tips data set first of all. So let's try to understand like how my tips data set looks like. So tips dot, I can try to like call like a HEAD, tips dot head, and this is the tips data set that we have. Now, what is the meaning of this tips data set? So this is our data set, you can say like taken by a people or created by a people who try to go to the restaurant and then they try to offer a tips to a waiter, and yeah, so different kind of matrices you will be able to find out that what was the total bills, what was the tips, what was the sex of the particular person, and then smoker, non-smoker, days, what was the day, what was the time, whether it's a dinner time or it's a lunch time, and what was the size of the groups. So this is the data set that we have. So this is called as a tips data set. So again, I'm trying to load this data set from the library itself. That's the reason I have written sns.load data frame, because I need some sample data set so that I can show you all the implementation. Now, so this is the tips data set. Now I'm trying to call a relational plot, real plot you can say. So in a real plot is almost equivalent to your scatter plot that we have done in matplotlib. So I'm trying to call like a sns.real plot over here, and then like I'm trying to give x-axis, I'm trying to give a y-axis. So x-axis buys a total bill, and then y-axis buys tips. So it is going to show you that whether there is a relationship between a total bill and the tips or not. And just by looking into a data set, you can say that yes, if total bill is going to increase, so for sure there is a very high chances that a person is going to get a high tips. Just a trend I'm trying to showcase. So here you will be able to find out that I have a data set, total bill was very high, and again tips was very high. This was the highest tips that person was able to get. Tips was almost $10, and this was the total. Data set is equal to tips, which I am trying to mention. So again, I'm trying to call like a C1 library, C1 relational plot or real, and then like I'm able to plot it. As simple as that. Now, so here I'm trying to do one thing. So I'm just trying to call like a tips column. Tips like a data set, and smoker column out of that, and then value to score count. I know that like what value to score count does, so it will always try to perform the group by count operation. So fine, not a problem. So it is going to perform a group by count operation. So we have basically a smoker and no smoker. So no smoker wise I have this many number of person, and smoker wise I have a 93%. A simple statistics I am trying to withdraw from the data set as of now, that how many smoker and how many non-smoker was there. Now I'm trying to call a relational plot. Let's try to, there is no like relevance between this and this. So I'll try to show you that the histogram based on these things. So this is basically a result of the histogram. You will be able to find out, which I'm going to show you maybe after some section. So where I'm trying to plot a categorical plot, cat plot basically. Yeah, so cat plot. Okay. Fine, I'll show you a cat plot histogram. So here you will be able to find out that it's completely fine. So we were trying to draw a graph like x versus y. So x was the total bill and y is nothing but a tips. And then here, so again, I'm trying to like do a relational plot. So x is nothing but a total bill and y is nothing but a tips. This is what I'm trying to plot. So x and y. Now, so data is equal to tips. I'm trying to provide whole data frame out of that. So it will select a tips and then total bill column. Now we are trying to set one thing called as hue, and then we are trying to set another thing called as a style. So hue wise, I'm trying to pass a smoker column. As we know that like inside a smoker column, we have two kind of value. One is yes, another one is no. Style was like I'm trying to give which column? Time column. So time was 2. So basically it was a lunch time or it was a dinner time. So fine, this is the two different value which I had inside the time column, and this is the two value which I had inside the smoker column. So hue and style I'm trying to set over here. Now what is the meaning of hue and what is the meaning of style? So let's try to look into a data frame as of now. So tips and tips.head. So fine, this is the data frame that we have, and here so we have like these two data. So equal to smoker and style is equal to time. So it's completely fine. So here it's the same graph it has plotted. Whatever graph that we have plotted before with the help of this only this x and y value, it's exactly same graph. There is no differences in between the graph except the representation. So here like hue is equal to smoker that we have given. So inside this smoker column, so we have either a yes or either a no. So in a smoker column, either we have a yes or either a no. Time wise, either we have a dinner time or either we have a lunch time. So what it will do by default is, so hue means it will try to give a different color representation automatically. So hue wise, so we have a smoker and yes and no. So yes wise blue color, no wise orange color. Now style it has given as a time. So again inside the time, so inside the time column, so we have a lunch time and we have a dinner time. So again it will try to give a different kind of a styling, like a square or like a cross or like a round or something like that. So for lunch time it has taken round, and for a dinner time it has taken a cross. Now so if you wanted to know that, okay, so what was what was a total bill of a person who came for, or like if you wanted to know any kind of a detail about this person, so just by looking into this graph you will be able to find out some details. So this person which is been represented by a cross orange, so I can clearly say that this person came for a dinner or maybe a lunch. I can give this answer. Or this person was smoker or this person was non-smoker. So even I can give an answer just by looking into this particular graph. So this person has paid almost like a $48. This person has given a tips almost like a $9. You can say $9. This person has given this much of like a tips. Plus this person was a non-smoker, because color is representing what? It's no in a hue. Color is orange. Now cross means what? So cross means this person came for what? Came for dinner. So this is what a kind of interpretation you will be able to find out. So in a single graph itself, so we are trying to represent so many things. So here if I'll talk about this person, so this person has given almost a tips of $1, bill was this much. Blue means this person was smoker, because blue color representing hue means color. So hue wise smoker, so yes, person was smoker, plus this person came for the dinner. So all the like a data which is represented over here, which is represented by a cross, so basically they came for dinner. All the data which has been represented by a round, so all of them came for a lunch, because this is representing a style. Basically all the data which is a blue, so basically so they are smoker. All the data which is represented by a orange color, so basically they are a non-smoker. This is how you are supposed to read out your graph. So if I'll tell you that, okay, so like label all of those people who came for lunch and then they are smoker. Lunch and smoker means all the dots, basically all the dots with a blue color. All the dots with the blue color came for a lunch over here, and then all of them are smoker. So this is how you will be able to find out each and everything. So this is how you will be able to like include any other column which is not a part of your x and y, and based on that, so you can try to plot a graph. Basically again same thing I'm trying to do over here. So we have a x column, we have a y column, same tips and total bill. Style was I'm trying to give size. I have not mentioned hue over here. So style wise I'm trying to give size column. We were having a size column, and inside the size column I have a 6 different kind of a size. Size means the bunch in which you will come to my restaurant, let's suppose. So like you can come alone, you can come with 2, 3, 4, 5, 6 on all these things. So style wise I have given a size. So yes, automatically what it will do is it will try to give a different label to all of those size. So size 1 means round. So wherever you are able to, if I'll ask you that, okay fine, so are you able to find out anyone who came alone in a restaurant? So yes, I can find out over here. These people are like came alone. This is like a round, and again I can see that the tips was very less and then bill was very less for them. Now, so if I'll talk about like, okay, fine. So are you able to find out some groups who came with the size 6? No, so yes, there are some people. So who were having a group size is equal to 6. Now, if I'll ask you, okay, fine. So can you please find out that, okay, so the person who is coming in a pair. So yes, I will be able to find out, like most of the person in this area is coming in a pair, and these are the average bill. You will be able to find out, and then you will be able to find out the tips. So yes, I am trying to do the same thing. So system automatically try to perform the grouping operations internally, and then based on the grouping, so it will try to label your data set. This is how easy it is to plot a graph in a Seaborn again. So yes, I will try to talk about many things. So I have already uploaded a file. So just try to go through this file as of now, because tomorrow, so again, I'm going to continue your discussions from the same place. So we have to talk about the Seaborn first of all, and then third, we will talk about the in Seaborn. So you will be able to find out many different kind of a graph. I have not included this box plot things into matplotlib, because anyhow, I'm covering these things in a Seaborn. So it's just a library references. And again, I'm covering into a plotly. So just try to go through these kind of a graphs that is available over here. Someone was asking about a linear regression graph. So yes, linear regression plot is also available in a Seaborn, and which is also available here in your material. So I will talk about these things in tomorrow's class, Seaborn and yes, Plotly both. Plotly is a small topic. Whatever we have discussed into a matplotlib, it's exactly the same thing you do. So these are the total kind of a graph which I'm going to cover into a Seaborn. So it's already mentioned in this list. So I'll talk about all those things now. So I would like to take some question over here. So yeah, you can raise your hand and I will just try to unmute you. You can ask a question.
Sudhanshu, one quick question. You shown that Iris and Titanic. Can we see what are default data sets in the library? Is there any option?
Yeah, so there is an option called as a DIR, and you can try to like a pass a library name. You can search, you can see all those things which is available in this DIR. So it will give you the list of everything. Do it. Try this out at least by yourself.
Thanks,
If you can ask a question, I think you can do it by yourself.
Sudhanshu, I was
Yeah.
asking like, what's the difference between KDE and the histogram in the scatter plot?
KD and histogram. So histogram is basically a representation in terms of a frequency and the range, whereas like a KD is basically like it's a just a curve in which you try to showcase.
Yeah,
That's the only
Sudhanshu,
differences.
can you please explain the layout parameter in the last graph shown?
Which one?
Not in Seaborn, in matplotlib, please.
Okay.
The last subplots, there were 4 subplots in which we have mentioned as a layout 2, 3. It was like 59 or 54 line. Yes,
This one?
yeah.
2 cross 3, nothing but 2 row 3 column. That's it. So are we creating a 2 row over here? First row, second row? No? You're not creating it? Can I say this is a row 1, this is a row 2?
Yes, yes, yes.
So 2 row and 3 column, right?
Yeah, yeah, yeah.
Cool.
Okay, thank you.
Hi, Sudhanshu.
Question.
Yeah.
First question is that can we use these libraries for displaying in web pages, like if we have some dynamic data or changing?
Yes, many people have done that in my class itself. If I remember, okay, let me give you one example. Like many people have done that. I'll just show you just a minute.
And the second question is, how do you choose between which library to use? Because both some of these
You
libraries
can use any libraries, ma'am. So you can try to practice with any libraries, and with whatever libraries you find yourself comfortable. So you can use it. There are another 150 libraries which is available. You can use again another 150 library as well. But yeah, these are the famous one.
There's no performance difference between them?
Performance differences you will not be able to find here. So performance difference depends upon your data set.
Hey, hi Sudhanshu.
Yeah.
Can we have real-time data is getting feeded, and based on that real-time data is getting feeded?
No, sir. You will have to run into a batch mode. So real-time data feeded is not possible. Again and again, you will have to call a refresh option. So means again and again, you will have to like call these things anyhow.
But can we automate it, giving a time frame like 5 minutes?
You
10
can.
minutes, something?
That is again, it's not a real time, right? So it's basically a batch. So
At least
it's a batch basically, right?
Right, right.
Yeah. So batch wise, yes, you can automate it. You can schedule it. There's no problem.
Okay.
Yeah.
Thanks.
Scheduling is always possible.
but based on that, we can see this graph, right? So every maybe 3 minutes, 5 minutes, 10 minutes, we can see the updated one.
That we can do. That we can do for sure.
Okay, thanks.
Yeah. So I'll just show you, like many people have submitted this challenge things, and many people have created a beautiful graph, I would say. Many people have they really worked hard. Yesterday I was sitting with my team to evaluate almost all of you, and let me show you some of the beautiful graph which people have created. And finally, we have decided 3 winners. So you all will get a mail as well, and we are going to publish their interviews as well. So let me show you. Some graph that I remember. Video link, this one. Okay. So yeah, see, people are doing this kind of a things. So people have submitted a solutions, right? Are you able to see it? Yeah. So people have created, they really worked hard, and they have created a very interactive graphs for this coronavirus cases that we have given to them. And yes, so there are many people have submitted their solutions, and you can create any kind of a graph that you want. There is no restriction with that, and yeah, everything is possible. So that's the reason. So we are talking about 3 libraries, so that in later stage you can pick and choose any of these libraries, and then you will be able to build your own things, right? So here what people have done is they have hosted all those things in a Heroku cloud platform, and then based on that, so they are trying to represent it. Yeah. So we have received hundreds of, I can say, solutions, and yeah, every solution was good, but we have our own evaluation criteria, and based on that we have evaluated. So this is again a use of graphs that people have created it, and people have done that. So yes, any other questions do we have? Any questions? So we have done with the class, today's class. If you have any kind of a question, you can go for that. Anyone? Yes? No?
No, Sudhanshu, you cleared it when
okay,
you were
fine.
explaining to somebody. Yeah.
Okay, fine. So fine. So I think we don't have any questions. So in that case, I'll take a leave, and thank you so much for joining the class. See you again tomorrow's class. Okay.